Hi, this is Ashley with Science Fair Friday, which is a series of short videos to help teachers incorporate Science Fair into their weekly lesson plans. And this week we are going to be talking about getting your students to invest in a topic. And this actually is one of the hardest parts of Science Fair. You ask them to come up with an idea and either their mind is going a million miles per hour, coming up with really elaborate, cool, interesting things that are not possible, or they're a complete blank slate and they have no idea where to even begin. And the first thing you have to do to help them overcome this is give them enough time. You really cannot rush this. It's a creative process. If you rush it, you're just going to get something low quality, something that they're not interested in, and something that they just find online that their parents do for them. So I know you want your kids to come up with these creative ideas. So we have a few strategies in this video to help you get your kids started. The first thing you need to do is explain what the science fair is. We say science fair, but it's actually the science and engineering fair. So there's two types of projects. The experimental project is kind of your traditional science fair project. The student will ask a question. They will form a hypothesis, and then they will measure variables. Engineering projects are similar, but there are some differences. So instead of just asking a question, they're going to be defining a problem they see and then just trying to come up with a solution in the form of a design goal. From there, they're going to construct a device or make a computer program that's going to follow that design goal. So they kind of have parallel structures. Over here we have the experimental project does mint cool water down. And so the variable that he is measuring is the temperature of the water. The variable he's changing is whether or not the water has mint. Versus the engineering project, or they wouldn't remember to close their garage door, which was a problem. Nobody wants their car stolen, right? So they came up with a device. They had a sensor attached to their garage door, and if it was open at 9 p.m., it was attached to a program which would then email them telling them, you need to close your garage. Most people, when they hear science fair, this is what they think about. An exploding baking soda and vinegar volcano, and I love a good chemical reaction, but this is not a science fair project. And no matter how beautiful the solar system is, we don't want to see it at the science fair either. The problem is these types of projects are actually just demonstrations, and we don't want the students to demonstrate their knowledge of science by just telling us about it. We want them to actually do science. They're going to become the experts. They're going to become the scientists and engineers. It's a completely different experience. But there are three things that every project needs to follow, three guidelines for a good project. The first, it needs to be possible. Like I said, you're going to get those students with these big, lofty, grand ideas. They're going to cure cancer, or they're going to create a nuclear power plant with clean energy, or whatever they want to do. You're going to have to rein them in and tell them to find something that's more possible. It needs to be possible. It needs to be safe. It needs to be affordable. The second guideline is it needs to be measurable. If you can't measure it, if you can't collect data on it, then it's not really science. You have to be able to graph and analyze the data in order to know if your hypothesis has been supported or if your design goal has been met. And the third thing, it needs to be interesting. And I'm not talking groundbreaking discovery. It just needs to be something that they are interested in. If it's not interesting to them, then they're not going to be invested in it. So you need to give your students lots of examples in order to help guide them to good science fair ideas. So I'm going to have this document in a link in the description. It is Science Fair Questions, the Good, the Bad, and the Ugly. Go over these with your students and have them brainstorm their very own good, bad, and ugly science fair topics. Another document I want to give you is projects often done by students. We've seen these a million times. They're not original. If your student is in love with one of these ideas, you can have them alter it a little bit so it's a little bit more interesting, but generally try to steer them away from these. So one thing I like to do when I'm introducing the science fair is do a little science experiment right there in the classroom. This actually gets the kids really excited, and it shows them it doesn't have to be complicated. You can come up with a question that you can actually answer. And the question this has is, who likes science more, boys or girls? And then right there in class, we tallied it up and we graphed it. We talked about what makes a good graph, how do we analyze the data, what conclusions can we form. It's just a really fast way to get the scientific method out there. The other thing I like to do is called the Draw a Scientist test, or I tell them that it's called the DAST, which kind of sounds like the SAT, and it's a little bit scary. So I get them scared about it on purpose. Oh, we've got a pop quiz. It's the DAST. This has been distributed worldwide. It has been studied by actual scientists to determine stereotypes of scientists that children have. So the directions I give them are simple. Draw a scientist doing science. And you find that they generally draw these stereotypical mad scientists, old men in labs exploding things. Once they're done, then you have them score it by having them tally up points. 1 point if they have glasses. 1 point if there's a lab coat. 1 point if there's an explosion. 1 point if there's a boy. And then you get some girls gasping like, why would they get points if it's a boy? But the point is not that it's better if you get high points, obviously. The switch at the end is actually scientists come in all different shapes and sizes, doing all sorts of different things, that everybody can be a scientist, and that the students, will become scientists by doing the science project. And it doesn't have to be in a lab. It can be outdoors, in nature, observing butterflies, or it could be doing sports. This student had a question about curveballs and did a science fair project on it. This student did a project about packaging of products and how that changes our perception of taste. Do you think it tastes better if it is name brand Captain Crunch versus the store brand? Does washing your clothes with fabric softener affect the flammability of the clothing? Does temperature affect the strength of a magnet? The thing is, anything can be science. It can be sports. It can be music. It could be clothing. Whatever your students are interested in, they can apply the scientific method to it and then come up with a great question. So right here we have an engineering project. They wanted to develop a device that would help your bananas ripen all at the same time, which is interesting. I'm curious how it works. But that's a real world problem that somebody might observe, and this is their solution. They came up with it. And here we have another engineering student. She developed a jacket with signals, so she could alert the people around her what direction she was going to turn. It's great, a great idea to solve a very real problem. So before they come up with a topic, they need to kind of survey their own interests. What do they like? What are their hobbies? What do they want to be when they grow up? What science do they like? Another great strategy is having them do some online research. So what is current right now? What's going on with the environment? What new discoveries have we made? And can you come up with a problem or a question that's relevant to these topics? And once they have a few ideas, have them brainstorm it by clustering and using those clusters to come up with very specific good questions that could lead to science fair projects. Have them bring their notebook home and come up with observations from their home life or from their after-school activities that they can use. So I hope you find some of those activities and strategies useful. If you have any strategies you've used in your classroom that you found successful, please comment below and share those with everybody. Next week, we are actually going to be talking about doing the research. Thanks for listening, and don't forget to subscribe.